be talking about corrosion in small diameter piping systems today. Basically, if you think back to the early 90s, the EPA enacted the Clean Water Drinking Act, which caused the municipalities to do something a little different to their water supply and the way they treated it. The water municipalities under this Clean Water Drinking Act were to remove gnomes, or natural organic matter, from the water supply. What gnomes were or are just natural organic matter in water lines. When you open a pipe and you see there's some kind of discoloration on the inside, kind of a dark patina, that's what this gnome was creating, kind of a natural corrosion protectant barrier. The Clean Water Drinking Act caused the water municipalities to change their treatment process from using chlorine to treat their water to using a chlorine and ammonia combination, of chloramine. By doing so, the chloramine removed this natural organic matter in the water supply and caused this kind of epidemic of pinhole leaks that we've seen nationwide, from probably the late 90s on, and it's only just going to get worse. If I could talk a minute on the effects that maybe a low pH have on a water supply. If you're familiar with copper pipe, you go into like the general store and you see that there's a little tag on it that says, oh, by the way, if the pH is below, I think it's 6.5, then some form of corrosion control is going to need to be used. We believe that E-pipe or an epoxy line coating on a water line is an excellent method for barrier coating copper pipe. Not only are you getting this corrosion issue and this leak issue, but at the same time, the solubility of lead and copper in the water line. For example, if you've got a copper pipe that's been sweat with lead solder, the homeowner is ingesting the lead and copper as it's being removed out of their existing water line. Essentially, the house that they live in is slowly poisoning them because the water is so clean, so aggressive that the lead and copper are leaching into the water supply. Now, kind of talk about corrosion. The visual way that we see corrosion is through leaks or pipe failures, and a lot of people think that through things like velocity or temperature or poor workmanship are really the causes for failing piping systems, when really it has to do with the chemical makeup of the water itself. The corrosion is happening because the water is so clean that things like temperature, poor workmanship, velocity are very small when you look at the big picture. Now, in this whole conference is about being green and looking at new technologies in ways to look at conventional problems. Well, the conventional problem is leaking pipes and pinhole leaks and failing piping systems. The conventional solution would be to just rip it out and replace it, causing landfill waste, causing all kinds of issues after the fact. Now, if you want to think unconventionally or think using a different method, you restore an old car by stripping it down and replacing all the pieces, painting it, what have you. Why wouldn't you do the same to your piping system? Why wouldn't you drain the water, sandblast the inside, and coat it with an epoxy. The ACEDuraFlo has been very successful over the last 10, 12 years in removing this type of stigma that pipe restoration it doesn't work. We've proven over the last, throughout our history, that taking an existing piping system, removing the existing patina or corrosion that exists, not only copper but in galvanized as well. Galvanized, you have the buildup of encrustation, but removing that and then coating with an epoxy, eliminating that water to metal contact. And by eliminating that contact, you then create an environment where water can go through that system. The homeowner doesn't have to worry about any type of corrosion that's occurring, and it's going to last, for 50 to 100 years or longer. I'll kind of open it up to the table for questions.
Can you do it on an existing system, and how long does it take?